Section 13.6, Equilibrium in Saturated Solutions. Check out video problems 77 and 78. They'll really help you out here. I'm just going to be talking about the concepts in this video. All right, so what we're talking about here are slightly soluble salts. Okay, so these are going to be ionic compounds that our solubility chart says are insoluble. Ionic compounds that are insoluble. Okay, so this is a specific example of equilibrium. Right, so the special kind of equilibrium, we call it KSP, where SP stands for solubility product. Right, so SP stands for solubility product. All right, and the terms here are pretty important. So KSP, that's actually what's called the solubility product expression. Okay, so that's the solubility product expression. And then, well, let's get to it here. So here is calcium oxalate. Calcium oxalate is slightly soluble, but when it breaks up, so when I throw this in water, some of it does dissolve, a very, very small amount. And so it breaks up into the calcium ion and then the oxalate ion. And since it's in equilibrium, I can write an equilibrium expression. So here is that equilibrium expression. Notice that calcium oxalate, the solid itself, does not go in the expression. That's because it's a solid. We only put aqueous and gaseous reactants and products in the expression, and so this is all I have. Now, remember what the square brackets means. In this case, it means molarity, right? I'm going to sneeze, hold on. Paused it just in time. So here we're talking about the molarity, right? And we can actually call that the solubility as well. If I could spell. Now, take a look. This is solubility. This is solubility. What do you call the answer to a multiplication problem? The product. So that's why this is the solubility product. Right. Now take a look at the one right below it. This is calcium phosphate. So calcium phosphate breaks up into 3 calcium ions, 2 phosphate ions. And so when we write the equilibrium expression, KSP is equal to calcium cubed times phosphate squared. Okay? And again, inside here, this is the solubility or the molarity. We can also calculate, so not only can we use this to calculate the solubility product, but obviously we can also use the solubility product to calculate the molar solubility. And so when you look at the practice problems, I'll go over that as well. Now let's talk about a special case of Le Chatelier's principle. This is what's called the common ion effect. Okay, remember Le Chatelier's principle is a system has reached equilibrium. We're going to stress that equilibrium. Okay, so what we're going to do is we're going to take a slightly soluble salt and we're going to add it to a solution that contains a common ion. So let me show you what I mean. Now there's different ways you can do this. What we're going to do is we're going to say here is a solution of, I'll go with this here, here's a solution of magnesium nitrate. Now nitrate is 100% soluble. So in other words, this magnesium nitrate it's a strong electrolyte, it's 100% soluble, it breaks up completely. It is not in equilibrium, it is a one-way arrow. So inside this solution, I actually have magnesium ions, and for every one of those, I get 2 nitrate ions. So I'm going to draw a nitrate, I'm going to draw another nitrate. Okay, so that's what's in there. Now, the question is, if I throw in magnesium carbonate, which is slightly soluble, so this is magnesium carbonate, so if I throw that in, how does that affect the slight solubility of the magnesium ion? Well, we've already got magnesium in here, right? And for this magnesium carbonate, there's only so much magnesium that can actually dissolve. So what happens is, in this case, it's got a common ion between the magnesium ion from the nitrate, the magnesium ion from the carbonate, so it's going to shift to the left. And what that means when I shift to the left in this case is that means I'm going to actually form more solid magnesium carbonate than I should. So it's going to precipitate out. It's going to come out of solution. All right. Now the other way that you can see this sort of problem is you can say, all right, here's this solution of magnesium ions. So it's magnesium with something else, but it's 100% magnesium ions. And here's this solution of carbonate ions, like that. When I mix these two, what's going to be, what's going to happen? Is it going to precipitate out? In other words, am I going to form a solid? Is it going to be completely dissolved? Well, that all depends on its KSP value. Okay, and again, sort of the same idea, not exactly common ion, but sort of the same idea. I think once you look at the practice problems, I think you'll be in good shape.